Welcome to the 2021 Data Platform Summit. Today's session is about a great innovative technology called Serverless SQL Pool in Azure Synapse Analytics. Hello, I'm Bob Ward from Microsoft, a principal architect on the Azure Data team. I think you're going to love today's session. We're going to unpack for you what is Serverless SQL Pool and why would you use this? Then we'll talk about the architecture of how it works under the covers. And we'll finish by talking about an exciting new technology called Synapse Link. Now you're probably wondering today when you see the deck and the demos, how do I get this information? And on this screen, there are URLs where you can download the deck and demos today. We'll put this up again at the end of our session in case you miss seeing it right now. I'm really excited today to be joined in today's session by my colleague Anshul Rampal, a senior program manager in the Synapse Analytics team. Anshul, why don't you walk through and start this session by talking about what is Serverless SQL Pool?
Thanks, Bob. My name is Anshul Rampal. I'm a senior program manager at Microsoft, working in the Azure Synapse on Analytics org. And in my role as a PM on the Azure Synapse team, I work very closely with a lot of our customers as they onboard to Azure Synapse and look at their journey, their pain points, and all of the things that they experience. And then I curate that information and then I work with the larger PM org to really help improve our customer experience. So it's a really fun role because I get to, not just sit behind the desk, but be in front of our customers and then engage with them deeply. So yeah, that's my role. Been with Microsoft for about 4 years, and it's been, and all along those 4 years, I've been in the Azure Data org. Now, for today's presentation, I'm actually super excited for this opportunity to talk to you all about Serverless SQL Pool. Actually, through DPS, we have this opportunity to engage very deeply with Microsoft data professionals and share all of the latest tech and innovation that's happening in this space. So I'm super excited to be here and talking to you all. One other reason that I'm excited for today's session is, again, I get to co-present with Bob. And for me, that's a career milestone. So thank you, Bob, again for joining me. And then let's get started now. With that, let's jump into the presentation since we have lots to cover. Now, Serverless SQL Pool is a new tech that is baked into Azure Synapse Analytics. And it's really unblocking a lot of data exploratory and data analytics scenarios that were not possible in the past, or you had to take a bet on other technologies, which is not always easy or even useful. But before we jump into Serverless SQL Pool, I would like to give you an overview of Azure Synapse Analytics, the thought behind it, how this all started, and then we'll jump into talking about how you use Serverless SQL Pool, the scenarios and the features, and then look at some cool demos before I pass it on to Bob. Azure Synapse Analytics is industry's first unified cloud-native platform for converged analytics. For those of you who know Azure SQL Data Warehouse service or have used that in the past, you'll know that we had Azure SQL Data Warehouse for about 4 years in the market before we brought in Azure Synapse Analytics. And one of the pressing needs why Azure Synapse Analytics came into being was we looked at a lot of our customers using Azure SQL Data Warehouse, and we found this common theme where customers were spending a lot of time building the ecosystem around their core data warehousing service, right? They were stitching together a lot of other big data technologies, data factory, all other Azure services and non-Azure services to really lighten up their reference architecture for end-to-end data analytics scenarios. And what felt as the right thing to do as the next version of the Azure SQL Data Warehouse product was to bring these other tech, the non-core data warehousing tech, into the umbrella of Azure Synapse Analytics, where customers have this turnkey solution ready as soon as they provision a Synapse workspace, and they can start ingesting data and realizing value from the data, rather than spending weeks and months stitching different technologies together. So that was the genesis of Azure Synapse Analytics. We launched the brand and the MVP 18 months back. The service went GA last December, and since then we've had thousands of customers, old customers who've been using SQL Data Warehouse and net new customers who've come to Azure Synapse Analytics because of the unique value proposition that it provides, right? The first, of course, is simplicity at scale, right? Like that's our core mantra. It is a unified experience that provides SQL Engine, Spark Engine, and other key Azure services right under the umbrella of Azure Synapse with a common experience around management, monitoring, security. So you don't have to worry about all of the ecosystem. It's all provided to you through this single Synapse workspace. Of course, you have the traditional data warehousing capabilities, but we've evolved that to include big data processing and data integration in the single cloud service. And it's important to note the differentiated value prop. Whereas other vendors might propose a Lego block-like approach, where they'll give you all of these building blocks and you'll have to stitch them all together to make it work, or alternatively, provide a single data warehouse service, we'll have to take massive dependency on other vendor solutions to complete the picture. But with Synapse, all of that is available to you through a single native experience. In fact, when you're provisioning Synapse, you just enter a minimum of 8 pieces of information, like your resource name, your workgroup name, your network settings, storage account, and within minutes, a workspace is provisioned with a complete set of capabilities, including a SQL engine that includes dedicated and serverless, your Spark engine, your Synapse pipeline, your data lake account, which is ADLS Gen 2 that comes attached with the workspace, or you can use your own ADLS Gen 2 account and attach to your workspace. So all of that information, all of that is available to you through the single Synapse experience. And this is really resonating with a lot of our customers. As I mentioned, we've previously spent a lot of time, on simple things like maintaining their infrastructure so that, for example, their for virtual networks, or even maintaining interoperability across services. As I mentioned, SQL Engine is of course our core piece in Synapse. And it comes with different modalities in the current version of the service, right? So we've always offered the dedicated model, which you see here on the right, which is an elastic cluster where storage and compute are separated, and customers only have to pay for the cluster size based on their uptime. This form factor also provides a hierarchical cache to provide the highest levels of performance, especially geared for your traditional data warehousing scenarios where query performance is required in milliseconds. So this dedicated form factor, as we say it, is really ideal for migrating your legacy enterprise data warehouses into Synapse. The newest addition is the serverless form factor, which is a pay per query model. And I'll remind you that this is also generally available today. And this is really geared towards your ad hoc query and data transformation over the data lake using T-SQL. Mind you, that's the most important thing, that you reuse or continue to use your existing T-SQL skills to leverage or use serverless form factor for, as I said, unblocking a lot of your data lake exploration and data analytics scenarios. This is really optimized for open columnar formats or the typical file formats that you'll see in your data lake like Parquet and ORC, but also for your semi-structured data like your CSV files or JSON files. We've also built in subtle productivity enhancements such as schema detection of delimited files, whether it's a comma, pipe, tab, or other delimiter that you need to describe in your query, and also has the functionality of identifying your header rows. The schema detection issue, of course, is easy for Parquet files since they are self-describing, but delimiter becomes a little tricky. But nevertheless, it's a great feature for our customers to have. We have many customers using serverless today for production workloads. And in conjunction with Power BI, they're populating in-memory data models directly from the lake using serverless SQL queries. And this has proven to be highly, highly effective for some customers. Now, this slide uh, describes what I just mentioned in the previous slide, but in a more easy to consume manner. On the left is your dedicated SQL pool, and on the right, it talks about serverless SQL pool. As I said, SQL dedicated is your classic pre-provision form factor, ideal for migrating your legacy workloads, legacy on-prem or data warehouse workloads, where the storage is optimized, and features like materialized views and results at caching allows you to get you a millisecond response. You pay per DWU provision, which is the data warehouse units, starting from DWU 100, going up until I think 30,000 DWs, based on the workload performance that you expect. Whereas on the other hand, SQL Serverless is really best suited for on-demand querying of files over your data lake. It's less about millisecond response here, but more about your ability to query ad hoc data over data lake without ingesting the data onto your dedicated pool or into your database. Without doing that, you can start querying your files and even linking, as I mentioned, your Power BI through those queries so that your BI users can start seeing value from their data without the need to move the data into your database and then transforming it and all of that. Now you must be thinking, this is great, right? But why are we adding this complexity of two different form factors? One is dedicated, one is serverless. And you're right. It is complex if you're seeing this for the first time. But like anything else, this is a journey that we are taking. And our ultimate goal is to provide a unified SQL experience that caters to all enterprise scenarios, like your classic data warehousing scenarios to BI queries to querying data lake, and with support for formats like Delta Lake, your streaming data, and including hybrid scenarios where you sometimes have to query, or in fact a lot of times you have to query from your operational data stores like Cosmos DB or SQL Server in some cases, right? So our goal is to provide that unified experience that allows you to use T-SQL as a language that you've learned over so many years and continue to use that, but enable you to unlock a lot of scenarios around analytics and have access to the data in the most quickest form, and then give you options. Either you want to go pre-provision or you want to go query as a service model, but you have all of these options through a single unified experience, and that's our ultimate goal. Now, let me get into the fun bit of the presentation where we'll talk about different scenarios or use cases where using serverless would make a lot of sense. Now, let's get into the fun bit of the presentation where I'm going to talk about different scenarios of how you can use serverless SQL in your environment, and then also dig deeper into some of the features that are available to you through serverless SQL pools. Now, the first scenario is really, really common, which is around data lake exploration. You have a data lake or many data lakes with a lot of different files coming in each day. The files could be Parquet files, which is a columnar file format, or CSV files or JSON files. And those files could be uploaded through other services, or those are user uploaded files. It doesn't matter. You have a lot of data in your data lake, and you want to just crack open those files and see the shape and size of the data before you even ingest the data into your database, right? You want to look at the value of the data, even the fitment of the data. And serverless SQL does exactly that for you. You can just start exploring those files. It does schema inferencing for you, and it basically gives you a pretty good idea of what's in the file without really doing the copy and loading and moving these files into your database before you start exploring them. And the best part with serverless querying is that there is no infrastructure to set up or manage, and you only pay for the queries that you run. There is no ETL required, and your data lake can be queried in place. And as I said, there is no need to copy the data and do data duplication. So that's a really classic scenario that a lot of our customers get started with whenever they're playing with data with serverless SQL pools. Extending that theme from data lake exploration, the next scenario is around logical data warehousing. You can query the data lake. You can not only query the data lake, but also serve the results to your favorite BI tool using the familiar T-SQL interface. You can define external tables, views, and permissions for your BI developers to enable them to be productive without the need to load the data first. They don't even need to know that the data is residing in the data lake, which is pretty cool. And not just that, in terms of the logical data warehousing, you can also join external data sources like data sitting in your Cosmos DB or other IoT data that's coming from your streaming platforms. You can join that data and serve that data directly into Power BI, which and then start providing real-time insights, which is again a great scenario for in terms of time to insights. And the next scenario is about actual data transformation. You can actually transform the data in the data lake through a variety of options that are available to you through Serverless SQL. So this is actually great for materializing results that are often needed to optimize performance. You can once you transform the data, you store the data back into the data lake before actually moving that data into your database. So you're doing a lot of heavy lifting right in your data lake. That saves you time, that saves you energy to actually ETL the data and do the exact same things when your data actually lands in your dedicated pool. So all of these functionalities that were happening after the fact, now we're actually moving the needle to the right and allowing you to apply these kind of transformations and then either move this data eventually or hook it up to your BI tool. So those are some of the classic scenarios. And one thing that I really like about serverless, that there is a role to play for all of the different personas. So for example, if you are a data scientist, this, just the data exploration would be really cool, or you're looking at data lake transformation as a scenario for your data science persona. But if you are a BI user, the fact that you can query your data lake and then export those results onto your BI tools is great. For a data engineer, again, data exploration, data pipeline, all of those day-to-day activities that these personas perform are enabled through the serverless SQL scenario. Now that we've looked at the scenarios, I'm going to talk about some of the key features that are out there before I switch to the demo. Like I said, the first scenario is around easy exploration of files in your data lake. And in this case, there are a bunch of Parquet files. You just right click on those files and say select top 100 rows. And in a very low code, or in fact no code manner, you're able to start querying these files using the open row set command. And that's the key, right? Serverless SQL uses open row set command to crack open these files. And Bob is going to touch a bit more on open row set. And if you're not familiar with it, it's a SQL command that includes all of the connection information that is required to access a remote source, to access a remote source from an OLEDB data source, right? So this method is an alternative to accessing tables in a link server and is a one-time ad hoc method of connecting and accessing remote data. So Serverless SQL pool uses open row set to read all kinds of files. And the red block that you see here, this is SQL on demand. So basically that just highlights that you're using serverless to query these files and not the dedicated version that's also available in Synapse. The next scenario, or the next feature, is again supporting variety of files. In this case, you're querying CSV files and you're actually providing the schema, but it could be a Parquet file. And not just that, you can also use JSON functions to get data from the underlying files or to get data from Parquet nested types. So that really enables you to get quickly to the data that you want, even though you have large files that you haven't really ETL'd to your database. Right within your data lake, you can start deriving insights from the data that's residing in these files. Another cool thing that we've added in serverless is the automatic schema conversion. So you're not actually required to know everything upfront, and you let the serverless query work for you. Through schema conversion, it'll basically identify all of the different columns, and in fact it also identifies the header rows for you, which is a really neat feature. Today this is available for Parquet and CSV files because it's relatively easy to do schema inferencing for these files. One of the other features I really like about Serverless SQL Pool is automatic syncing of Spark tables. Now, in the beginning of the presentation I mentioned, and I know we haven't spoken much because our focus for this presentation is around serverless, but that we have a Spark engine right in the Azure Synapse analytics that allows your data engineers or your data scientists to start analyzing big data using Spark and the native notebook experience that's built into Azure Synapse. Now, for example, you have a data scientist or a data engineer or a data analyst, right, on the Spark side of the things, and they create a table on top of a Parquet file that's sitting in your data lake. Now, that table is created in your Spark experience, but as soon as that table is created, it's actually available to you in your serverless experience as well. And so you can start querying the files, start querying the table that was created using Spark SQL. Because we have a common metadata, any changes that are made to the table in Spark are reflected in SQL, and both these tables actually are referencing the same external file. So that is a really neat value add, because you can really save time and make sure that your data is in sync, even though different users are accessing it through different channels, right? So that's really a neat feature that is in Serverless SQL. You can create SQL views in externally stored data and then leverage T-SQL to process and analyze the data in external files exposed via views, which is again a classic BI scenario. You can then create Power BI reports on views, which is created on external data, which is where, as we looked at the scenarios, this allows you to quickly make the insights available by hooking your Power BI or other BI tools on top of the views that you create over your external data. Similar to views, you can also create external tables, but also join and transform multiple tables in a single query. This enables you to analyze external files with the same experience that you'll have in the classic databases. And I'll actually show you in the demo on how easy it is to do that and how beneficial it is for your scenarios where you're dealing with large set of files. You create these external tables and start joining them and quickly exposing the insights to either your BI tools or exposing it to the next set of services who are waiting for the data, right? So there is this whole process that becomes really seamless with serverless. Now, classically, we see a lot of users using Synapse Studio, which is our web IDE, but you can actually use any other client tools like Azure Data Studio, SSMS, or other tools to connect to Serverless SQL Pool, as long as you are able to maintain a TDS connection over SQL. So that's really any client tool that can do that. You can access serverless through that client tool. You don't just have to use Synapse Studio, but other tools that you're more familiar with, which is awesome, right? Now we've looked at the scenarios. I'm gonna now show you how things work in action and give you a better appreciation of the technology and the value add that it brings into your data analytics scenario. So let me switch to the demo. Now in this demo, I'm going to give you a quick overview of Synapse Studio. This is our Synapse workspace, and then dive into some of the features that enables you to do data exploration using Serverless SQL Pool. Now, what you see on the screen is our Synapse workspace enabled through Synapse Studio, which is a web IDE. A Synapse workspace is created in Azure portal. When you provision your Synapse, when you create a Synapse workspace, you get an endpoint that launches the Synapse Studio. And through that single unified service, you have all of the options available to do data analytics using SQL Engine, Spark Engine, and other data pipelines that you can create to start ingesting data from a lot of different sources. When you launch your Synapse Studio, the first thing a lot of customers or a lot of users come and start with is the Knowledge Center, which is basically, it gives you a getting started experience where we have pre-canned sample sets available to get you started on querying data with SQL or with Spark, or start creating external tables. We also have a gallery where we have data sets, a lot of different notebooks, SQL scripts. So this is all enabling you to really get acquainted with Synapse and get started in your with your journey to use Azure Synapse for data analytics. Now going back to the home page, I just wanted to quickly show you some of the options here. The first one is the data tab, and in this there is a default at a workspace level, all of the different databases that you've created. You'll see that you'll see SQL databases as well as Spark datasets. So all of that information is available to you right in the single view. Additionally, like I mentioned, we can also attach our, there is an option to bring in external data. Azure Data Lake Gen 2 is directly available to you every time you create your workspace. So either you use the one that comes with the workspace, or you can attach your other data lakes as well. In this case, I have my Azure Data Lake Gen 2. I have a bunch of different files in there. I have a blob storage connected, Cosmos DB, as well as Azure Data Explorer, which also I've added as a link service. And then you also have the option to connect to external data, and these are the options that are available today. In the Develop tab is where all the magic happens. So you can write all of your SQL scripts here. For example, your notebooks are all available, and similarly, we also have data flows. So for example, this is a sample data flow, which is bringing data from a Cosmos store, and then you're doing a bunch of transformations before you finally load that data into your database. Also, we also have Power BI. So for example, you can link your Power BI workspace, and all of the reports that are in your workspace are available to you to access in Synapse Studio. And so you can actually make changes to the reports here and they get reflected, or you go to Power BI desktop and make changes to the reports, and it's in sync once you attach your Power BI workspace. So that's a really neat feature that a lot of our customers love, and goes back to the whole mission of creating, stitching together all of these services so that you don't have to spend the time doing that. So let me close this. In the Integrate tab is where you actually create all of your pipelines. So that's all of the options to create a pipeline is available. And then Monitor. So you see here we have SQL pools, and then we also have Spark pools. In the SQL pools, the built-in is actually the Serverless SQL pool that's always online, and it's auto. And you see the type here as Serverless, and then these are all of the dedicated SQL pools that I've created in my workspace that I use for different purposes, ranging from 100 C going up to 3000 C for my NYC taxi pool. Similarly here for the Apache Spark pools, these are all of the Spark pools that are available that I've created. In my Manage tab is where I can, if I need to bring a pool online, I can do that. Similarly, this is where I actually create link services, as well as access control. So you can create new users, you can give them different accesses, and all of that happens in the Manage tab. So this is really a 30,000 view of different options that are available to you when you launch your Synapse workspace. But for today's demo, I want to look at Serverless SQL Pool, and we'll start off with a quick demo on start exploring files in your data lake. Now, this is a default folder in my Azure Data Lake Gen 2 storage account, and in that I have this Parquet file, and I really don't know what's in this Parquet file. So what I'll do is I'll say right-click New SQL Script and select top 100 rows. And like we saw in the previous part of the presentation, Serverless SQL uses OpenRowSet command to read this Parquet file and give me the results. So this is a query that was auto-generated. And what I wanted to highlight is that we are using serverless to query it, because you see this built-in function. There are also all of these dedicated pools that we don't want to use, and so we are using the serverless built-in function to run this query. And when I run this, it'll show me what's the content of my file before I want to really figure out what I want to do with this file. So it'll do automatic schema inferencing for me. It's picked up all of my headers and all of my and all of the data is available to me. So that is just a way for me to really know what's in this file, right? I could choose to also create an external table, or even bulk load this file into my database. But I don't want to do that. Let's see what happens when you create an external table. Again, this will basically create a table on that file. You're using the built-in Serverless SQL pool. You can select a database. For example, I choose NYT, and I just give it the name dbo.test. And I want to use a SQL script to create that external table. So when I click on create here, so you'll see that the script gets generated to create that external table over the Parquet file. That's my location, my data source, my file format, and all of my fields have been inferenced with their and the schema has been inferenced for me, which makes it a pretty easy way for me to start exploring the data. I can create, once the table is created, you can then do a bunch of transformations on it like you would for any other table using T-SQL. So that's really the benefit that Serverless SQL provides for quick exploration of your files in your data lake. Now I have a script open to just kind of show you in action how you would, some of the enhancements we've brought into Serverless SQL pool that allows you to seamlessly access and browse files. So in this case, for example, I have a pandemic file, data lake file. It's a CSV file. It has a lot of data around COVID-19 that is actually available in the knowledge center that we curated. So I want to just look at the top 10 rows in this file. So I'll use again my built-in Serverless SQL pool as my engine to run this file. And like that, it just shows me how quickly all of the data that's in this file, it's just the top 10 rows, but all of the fields that are in the file. But in my case, I want to explicitly specify what columns I really want to see in my output. So I can specify the columns as I'm exploring this file, right? So I just want to see these 3 columns: date, rep, cases, and GeoID, and that's what it'll show you. It'll just pick up the columns you want. Extending that further, we can also do window style new lines. So for example, in this case, we've used some collations, and there are a lot of other different options available for you as you query your files. For example, you can return a subset of columns. If you don't want all of the columns coming into your query, you can do that. So yeah, lot of different options available to you as you start querying your files. The very last thing I wanted to show you was just how easy it is to create a view on your files in your data lake, and then use some and you can run some aggregation queries to derive insights from that data. In this case, I'm using this file that is sitting in my Cosmos DB container that I've attached as a link service, and I'll actually Bob is going to kind of talk you through that in his section of the presentation. But just the simplicity of how you can start creating views and start doing complex data analysis on that data is what I wanted to really highlight here. So in this case, it's a file sitting in your Cosmos in our Cosmos container, and I'm just going to select star from that, and it's going to do schema inferencing for me. I didn't know really what's in that file, honestly, as part of this demo. So yeah, there is it did the schema inference and showed me every single column that's in the file. But I think what I want to really know is the product ID, the code, and the cost, and the base price for that, right? So let me just specify the schema and then run this file, and you'll see that it's gonna just show these 4 columns that I need to see for my analysis. Now, what I wanted to show you is that you can actually create views on top of this data and then start running some queries on those views, right? So here I have created a view with these 4 columns, and the view gets created in a quick second. You'll see that the view got created, and I also I queried, of course, from the view, which is cosmosdb.product, and this is just a sample report where I'm using an aggregation query where from the stored ID 80, I want to see the product code that's available, and I run this report on that view. And mind you, none of this data has been imported into your database. It's all in your data lake, but you're creating these views on external data and doing all kinds of transformations. And this is another query which basically calculates the sale price, which is quantity into price. So then the total sales that this store has done, and I can actually do that right here, and you're able to fetch your results, and I can then expose that data to my I link it with my Power BI, and you can start exporting those results that are available to you to your business users. And I think in this case I might have selected the wrong product ID, but anyways, this is just a way to show you that the ease of use of this data exploration. With that, I'm actually going to switch pass it on to Bob for the remaining section of the presentation.
Well, thanks, Anshul. Great way to introduce folks kind of what this is, what is this technology, and what are all the great use case scenarios from it, including a great demonstration. So thank you for that. Let's shift gears and talk a little bit about behind the scenes, how does Serverless SQL Pool work? You'll notice on the screen it says the word Polaris. One of the things I love working about at Microsoft is I get to meet and work with some of the smartest people on the planet. So it turns out the project name behind Serverless SQL Pool is called Polaris. And you see on your screen here a URL for a white paper written by the team at Microsoft that built this technology. You know, when I was trying to figure out the architecture of this, I was searching around within the company for internal specifications, internal documents, couldn't find anything. But then someone pointed out to me, it was Anshul, and said, Bob, what are you worried about? There's a public white paper presented at the VLDB conference on this Polaris technologies. And one of the cool things I love about this paper, which goes into great depths of what I'm about to show you, is we backed up our architecture with some numbers. Look here on the screen here. How about a 1 petabyte scale of all the TPCH queries we ran and used and proved with the Polaris technologies? So let's spend some time talking about how this works, a little bit under the covers of what the functionality we're using, which is all based actually on SQL Server, an enhancement we'll make to the great SQL Server engine. Okay, first of all, to talk about how Polaris works, Serverless SQL Pool, I thought it important for you to understand some of the technology that we're using that was introduced in SQL Server. Way back in SQL Server 7.0, we introduced a new T-SQL function called Open Row Set. Now, this is during the time where we're bringing along technology like linked servers. So OLADB is a very popular driver technology. And you look and you see here that we built the Open Row Set function in SQL 7.0 to allow you to retrieve rows from any OLADB data source using kind of like a dynamic query. Now, when we built this technology, we said to ourselves, I think people also want to retrieve data in unstructured files. So we included something called a bulk provider to read data from a file. And in fact, the file itself is a path. That path could be a URL, such as Azure Blob Storage. And the formats can be like a comma delimited file, or you specify a format file. This is now back in SQL 7.0. Now, this bulk provider was often used to import data. That's why it's called bulk. Folks would use the open row set provider with the bulk provider, the open set function with the bulk provider, to insert or to bulk insert data based on reading data from a file into a SQL table. Now you fast forward now to today with serverless SQL pool, and you can see here that we're going to use that same bulk provider functionality in open row set, but we're going to enhance the technology and make it work with serverless SQL pool. So first of all, there are new file formats now. Things like Parquet and Delta Parquet are more structured formatted files. So we're going to support those. In fact, it's going to be a very common pattern a lot of people want to use when it comes to things like data lakes. Our storage can be Azure Blob Storage or now an Azure Lake data store. And we're going to be able to use something called an external data source, which we'll talk about in a second. Now we support within this technology, because things like Parquet have information inside there, automatic schema detection. So we can tell what are the types of data inside files like Parquet. We even support filtering and partitioning to make things more efficient and faster. You can even project only specific columns from a file to make things even quicker to get back to only the data you need. And this is really what's considered the ad hoc method to query files when you're using serverless SQL pool. So get used to using the open row set function. Now, later on in SQL 16, we introduced a concept called polybase, and we built an abstraction called an external table. It was kind of like a virtual table in SQL Server, which was used to store metadata on top of a Hadoop file system. And once you created an external table, you would only store the metadata in SQL Server, not the data, but you would query this table like any other SQL Server table and even put things like security permissions on top of them. The data was all retrieved from HDFS. And then in SQL 19, we extended this concept of external tables to include other ODBC data sources, some built into the engine like Oracle, and even SQL Server, MongoDB, etc. Now, with serverless SQL pools, we can use external tables on supported providers. So for example, we can create an external data source and a file format on top of the same type of Parquet file format we talked about. And you're going to see later in today's presentation that one of those providers is now going to become Cosmos DB using Synapse Link. So the metadata is stored in something called the SQL front end. You can query the information, query the data like any other SQL table, just like SQL Server external tables. Unlike polybase, though, you don't insert data with using external tables in serverless SQL pools. But you may want to get smart about how you're caching data, so you can use a concept called CTOS, or create an external table as a select statement, where we'll actually take the results of the query you're running from the external table and store them back into the data lake into Azure storage. Okay, any good architecture discussion needs a diagram, and we've got one. This is actually extracted from the Polaris white paper. This is an overview of the various services that are part of what makes up serverless SQL pool. Now, it all starts at the big top here with something called centralized services. It's stateful. In other words, we store information here about execution across the pool, and actually it could be multiple pools. As it turns out, one of the great ways to do stateful storage of information is Azure SQL Database. So behind the scenes is Azure SQL Database, which has built-in redundancy, fault tolerance, HADR, everything we need to store information. But we want to make sure in the pool that things are stateless. That's the only way to get scale. Now you have to be able to connect in to run queries like open row set. And what better way to do that than connect to a SQL server? So an actual SQL front end, which is TDS compatible, is what you connect into to run your queries of open row set or create external tables to query information in your data lake or whatever provider we support. Now, once you connect and execute things within the SQL front end, this is going to invoke services behind the scenes for something called a distributed query processing system. It's going to coordinate scale across all the different compute servers we have that are really going to be actually running the queries to access the data. And then next, this distributed query processing set of services, set of software, is going to coordinate across something called compute servers or nodes. Really what they are back-end stateless SQL servers running a bunch of what we call tasks, which are effectively mini queries, where we scale and run all the things necessary to access your data. So you can see in this diagram here, a compute server is made up of a SQL server, some cache, which could be, actually, we could use the SQL Server buffer pool or local SSD cache, and execution services to help coordinate running these queries. So you can see already we're enhancing the power of the SQL Server engine to support TDS-compatible front-end queries, but then down below in the back end to execute in a stateless way a set of queries to access your data. And then finally, you have your data itself. Now, we started with Serverless SQL Pool with things in Azure Storage or Data Lake Storage, which were typically a set of files. There's got to be a way to get access to these files in a smart way, so we have abstraction of these files in something called data cells, which we'll talk about in a second. So you can see the entire diagram here. The Polaris pool or the SQL pool is made up of a front end of SQL Server, a distributed query processing set of services, and a set of compute servers which are going to run SQL queries behind the scenes broken down in something called tasks. Now here's one of the great things about the story of being in Azure. We get to use the power of the Azure infrastructure. So all the things you get for fault tolerance and redundancy of things like compute, networking, storage, we get access to all of that by running all of our services in our pool in the Azure infrastructure. And you think about trying to query data at scale, it's best to have some way of organizing that information to get information quickly. And so if you think about a data lake, it's usually made up of a bunch of files that in many cases are unstructured. So what we're going to do in the Serverless SQL pool is we're going to take these files and we're going to organize them in something called cells. Cells are a very great way to allow us to scale and partition out what we're going to do. And then we're going to get pretty smart here. We're going to use hashing algorithms to hash data in these cells. And based on what the user provides, we can potentially partition and slice across these to filter out and make things more efficient. Now, in those compute servers, we have a way of using the power of SQL Server combined with enhancements we've made in the engine to do things in something called tasks. Tasks are a way of mapping a cell or a set of cells to go query only the things we need and return the results to put things all back together. So the data lake is always going to be abstracted. Remember, this whole system is stateless, but we're going to have a way of caching information to make sure it's efficient every time we query the data lake. And we're going to use these tasks to break and partition out our work, again, using the power of SQL Server combined with enhancements we make to query the data. Okay, one of the key aspects of running serverless SQL is to build an autoscale. So let's say, like in this diagram here, these nodes, which are the compute servers, have a set of tasks running, mapping to cells in our data lake, and we need more. So we can dynamically, as we're running our workload, add more tasks to the mix as needed to give proper performance for your workload. But let's say we want to go even further. Let's say we need to even scale further to meet the needs of what's going on we found in these cells. And if there's compute available to us, we have the ability to spread and rebalance the workload across other compute servers to get maximum performance. So in this diagram here, we're using double the number of servers, but it doesn't have to be that. But imagine the scenario where we decided that we could get faster if we could just simply take all these current tasks and rebalance them across other nodes. Remember, we're stateless, so we can get away with that. We can do that. And so now, all of a sudden, our compute looks something like this, where we get much better performance because we've balanced these tasks across more than the compute servers that we started with. Another aspect of being able to run at scale and being very resilient is fault tolerance. So even though we have the back end of Azure infrastructure to help us with fault tolerance, we need to be fault tolerant within our own set of tasks that are running in our compute nodes. Let's say, as an example, we're currently running a set of tasks that look like this across 4 nodes. And we determine that one of the nodes has a problem, but we need to keep executing. And remember now, these tasks are stateless, so we can go grab information that we've got stored to tell these tasks to run somewhere else and keep picking up where they left off. So how do we do that? Well, imagine that we had these tasks spread across these 4 nodes and one had a problem. We can balance and move tasks to go run them on the 3 nodes that are left that are running and still just keep executing. Of course, if we had to, we could potentially scale if we need to at this point, but this is something that's very important for us to be able to do, to be resilient, and it is showing the power of being stateless when it comes to running our tasks. Now, I thought it'd be important as we finish off looking at the architecture for you to get a feel about SQL Server and how it's more involved in the distributed query execution flow of running one of these open set queries, open row set queries, or running an external table query based on open row set. So I mentioned before that we had a SQL Server front end that's TDS compatible. What does that mean? It means I can use Management Studio to connect and run queries to this, or other tools or apps that are TDS compatible. And I get all the benefits of metadata and security that I do from a normal SQL. And since the query processor is inside the SQL engine, it can be the starting point to do predicate pushdowns and partition elimination, things that the query processor in SQL is really good at to start the flow of execution. So the way this kind of works is that when the SQL front end decides to run one of these queries, it is going to be able to invoke what we mentioned before, distributed query processing services. This is effectively now a distributed execution plan that we build based on cost. We're going to use cost-based analysis, cost estimates, just like we do in SQL Server, to decide what is the best distributed execution plan to do this. And then this is where we make the decision to break up the query plan itself into fragments, are called tasks. And so what is a task run on a compute server? I showed you a bunch of triangles or circles. Well, you know what it is? It's a bunch of SQL backends. We determine how many SQL backends we need. Again, remember, they're stateless, and they're responsible for executing these tasks. We're going to use the great power that the SQL engine provides us with SQL-less scheduling, with query processing, to run these tasks, and then to go after the provider itself, and then to propagate the results back to the parent. So each task propagates results back to another level, and eventually the SQL backend that started all this from distributed query processing can send the results back to the SQL front end, which is where you connected to give you the final results of the query itself. Okay, that was a lot of diagrams and slides talking about how things work behind the scenes. I thought you might find it interesting to take a look at a demonstration of what does it actually look like to connect to a serverless SQL pool. And let's take a look more at what that SQL front end really looks like. Let's first look at Serverless SQL Pool by looking at the Azure portal for my Synapse workspace, just to kind of show you what you get. When you deploy a Synapse workspace, you automatically get the Serverless SQL Pool. In fact, we call it here built in. So it's a built-in pool that just comes with a Synapse workspace, and you see here the type is serverless. Now you want to know how to connect to one of these pools. So here is the Serverless SQL endpoint that we talked about right here. In fact, you look at it further here, this almost looks a little bit like a URL for a Azure SQL database. So that's going to be the actual URL you're going to use when you go connect with a SQL tool. One of the tools you might have seen to use, you saw Anshul do demos over this, is Synapse Studio. And I'm showing you an example of an open row set script, just ad hoc I'm running against a public data set. And I see the results here in a table. Hey, one real quick tip that I love about looking at this is just clicking on chart and you get a nice little visualization of my results. If you click on messages, it's kind of interesting. If you look pretty closely here, you will see some information about what is executed behind the scenes in the pool, about a statement ID, a query hash, etc. A couple of tools in Synapse Studio that you might consider is the monitoring tool. I can see, first of all, for SQL pools, I can see the built-in pool and get statistics about the history of what's been run against this pool, including how much data has been processed and how many different requests have been run. But I can also look at overall SQL requests. Think of these almost like as batches of requests that have been run against the serverless SQL pool. And I get information about when they were submitted, the duration, how much data was processed, who submitted it. And then clicking in here, I can even see information about what was the actual query text that was run. But hey, that's a Synapse look of the world. What about a SQL view of the world? Let's flip over here and look at SQL Server Management Studio. You will see here, I'm connected through Management Studio to that endpoint I just mentioned, and the icon looks a little bit like an Azure SQL database. If you see an Object Explorer view, notice this doesn't look like a full SQL Server instance. It's just showing you things at a database level, like you might see in Azure SQL Database. For example, one thing you can see is an external table that was created here. This is just showing you in the SQL front end that we mentioned in that architecture diagram, we can store metadata like external tables that can be used to query information. Now, let's run a couple of queries just to kind of see, is this really a SQL Server? What is this thing? Notice here when I ran add version, I see here it says SQL Azure. That looks exactly like add version when you run a query against an Azure SQL database. In fact, I'm going to select star against a catalog view for databases, and notice here, I see a set of databases like Logical Master and other databases that kind of make it look to me like an Azure SQL database. I can even select star from sys objects and go in here and see a bunch of tables and views that, again, look like what it might look like in an Azure SQL database. So this is a SQL front end we've implemented using Azure SQL Database, but it's not going to be the full SQL Server. Now, how do I know that? What if I just tried to create a table? Notice here, I'm not allowed to do that. This is a read-only system. The only thing you're going to create that's going to store information is things like external tables and external data sources. But here's what's interesting. Is it really a SQL? spconfigure returns back results. I can't change configuration. I wouldn't want to do that anyways. We use the front end and scale things at our own needs for your purposes. So that's just a little bit of a look at what it looks like to see, is this a SQL server? What about monitoring? Can I do things at the SQL level to monitor? Well, sure enough, here's a query using a popular DMV that you well and know, love, DM exec requests, joined with exec SQL text to see what is current requests that are running and what is the text that goes with them. So let's do this. Let's go run the query that I did in Synapse Studio, but let's do it for Management Studio and see if we can catch it in its state running. So here's that same query. I'm going to kick it off and go run the DMV, and sure enough, I can see information about that query and a wait type you've not seen before. That's an internal wait type about us coordinating distributed execution with our distributed query processor from the front end itself. But you can see the SQL text is the same query I was looking at. Now, if you remember back in Synapse Studio, we saw a history of requests that have been run in the serverless pool. I can get that same information inside of DMV, a new one called exec request history. If I click here, I'm going to run and see information that some of it we showed you in Synapse Studio, like who ran it, what was the start time, what was the text, what was the duration, how much data was processed. You could even actually see information about errors if they occur. Like, was this query run and canceled, or was a specific error came up because maybe it was an invalid location that you try to run against. So you can see things that this looks a little bit like a SQL server, but a little different than a SQL server. So Anshul has shown you the fundamental use cases and scenarios of how to use serverless SQL pool. I showed you some of the behind the scenes of the architecture and how we are using SQL Server and enhancing it to implement serverless SQL pool. Let's finish today's session by talking about a technology called Synapse Link. So what is Synapse Link? It's all about operational analytics, also known as hybrid transaction analytic processing. So today you might be using Azure Cosmos DB as a transactional store because we've optimized that for transactions using a row store technology. What we've also provided now, though, in Cosmos is the ability to have changes from the row store fed into an analytics store based on columnar storage, which is a better mechanism to do analytic queries. Now, what we've also done is provide you a way to link together your Synapse workspace with the analytics store from Cosmos and see it now as a provider. Just like the data lake would be a provider for files, Cosmos DB Analytical Store can be a provider for Synapse queries. This means I can now use the power of Synapse through serverless SQL to query the Cosmos DB Analytical Store, just like I might go query the data lake. Okay, let's see the step-by-step process of how you would enable Synapse Link and make it work with Cosmos DB. This will assume you already have a Cosmos DB account and a Synapse workspace in Azure. So the first thing you're going to do through the Azure portal is go to your Cosmos DB account and enable Synapse Link as an option. It's a very small, fast operation to do this. Then go in and create a new container in Cosmos DB. And when you do that, there's a new option called an analytics store. So you'll enable that option when you create your new container. Next, you're going to go in and connect Azure Cosmos DB with Azure Synapse Analytics. It's something you can do through Synapse Studio or through the Azure portal. Next, you'll start ingesting data into your Cosmos DB system. And in fact, one interesting way to do this is through Spark pools in Synapse. Since you're connected with Synapse with Cosmos, you can actually use Spark as an ingestion mechanism to put data into the row store for Cosmos DB through Synapse Link and then see the results in the analytics store. In fact, what you'll do is you can now run serverless SQL queries with open row set against Synapse using the new Cosmos DB provider. And of course, Synapse will redirect these queries against the analytical store. So remember our diagram about data cells with Azure Data Lake and Azure Storage. Now, Cosmos becomes a new set of data cells. We still use the same technology to look at the analytics store, which is in columnar format, and use the data cell with hashes and use our partitions to go access the data. So the same way we go after and look at files, we can now look at Cosmos through this concept called Synapse Link. And then if you think about Azure, look at what's possible now. Think of a scenario like IoT situations and scenarios with devices where we can feed data into Cosmos DB from IoT streaming, or even use Spark to feed that in, and then use Spark or SQL Serverless to go after the analytics store data. I could do machine learning models on the data itself in the analytics store, or I can just run queries like warehouse type queries that'll feed things like Power BI dashboards. Okay, let's look at a demonstration of how to use serverless SQL with Synapse Link to query some IoT data that's in a Cosmos DB database. In this demonstration, which by the way, just to remind you that the demos that we're showing all today are available to you in resources that we will show you here at the end of today's session. So in this situation, I have a Cosmos DB account and a Synapse workspace already. In my Cosmos account, I can see right here that I've got a database, Cosmos DB IoT demo, and two containers. One to store signal information from IoT devices, and one about properties and information about the device info themselves. Now, per the discussion of how to enable Synapse Link, you can see here when you click on features that Azure Synapse Link is set to a status of on, and this is where I would enable that feature for my Cosmos account. Let's flip over and look at Synapse Studio, which is where I linked or connected my Synapse workspace with this Cosmos DB account. You'll notice over here in the data part of Synapse Studio, when it says linked, I've got two pieces of information. One is the link to the actual Cosmos DB database, and then showing the two Cosmos containers. What's interesting, if you look here, notice this icon with the little bars. That indicates this is a container that is enabled for an analytical store. If that was a row store, you would not see the little graph bars next to that icon. In addition, I'm storing data in my data lake right here. As it turns out, what I've done is I've got the IoT signal data and the device data as a set of files in my data lake. So what I'm going to show you is how I've used a Spark notebook using a Spark pool in Synapse to go through and read data from the data lake for IoT signals and devices, and then use Spark to stream that information into Cosmos DB. Now, even though I'm linked to Cosmos DB in this case with Spark, when I ingest data, it's going to go to the row store, not to the analytical store, even though I'm linked together. So I can run here right now. I can click this cell and go start ingesting data through Spark for IoT signal telemetry into Cosmos. Over here, though, I have a serverless SQL query. Now, notice the similarities of what we've demonstrated before. I'm still using open row set, but the new provider here is called Cosmos DB instead of the bulk provider. And as part of that, here's the Cosmos account information, the database, and a key that you would have for permissions that you would get from your Cosmos account. And then finally, here's the name of that container, IoT signals. So what I'm doing is I'm going to kick off this query while I'm ingesting data into Cosmos. I'm running a query through serverless SQL to the Cosmos Analytics store. So this runs unimpeded from even ingesting data into the row store. So I can do row store ingestion all day, run my queries against my Analytical store because I'm using this Cosmos DB with Synapse Link. Well, now you've seen a demonstration of Synapse Link. Anshul, why don't you conclude today's session by showing our audience kind of a summary of what we've done today and giving them some great resources so they can learn more.
Thanks, Bob. That was a great demo. With that, I just wanted to put this summary slide up, highlighting some of the key points you heard from us during this talk today. You learned about Azure Synapse Analytics as the industry's first cloud-native platform for converged analytics, where we have SQL Compute, Spark, and Spark-based compute, as well as data integration using Synapse Pipeline. We spoke about dedicated SQL and serverless SQL. Bob also showed you the Polaris distributed SQL engine that provides you the ability to resize live workloads or even deliver predictable performance at scale and handling both structured and unstructured data. We showed you how serverless SQL can be used to start doing exploration of files in your data lake and all of the tech behind it. And then lastly, Bob showed you Azure Synapse Link, which is again a cloud-native HTAP solution that allows you to do analytics over your operational data in a very seamless manner. We've also put together a great number of resources for you to continue your learning journey after this presentation. You can go learn about serverless SQL pools, Polaris white paper that is published that gives you a really detailed description of how we've built the engine, all of the different characteristics. So I would highly recommend going through that, and some great videos, best practices. So yeah, all of these links are available to you, and I'll encourage you to go over those, and happy learning. And with that, a big thank you to all of you for listening in today. And thank you, Bob, for joining me today.
Hey, thanks, Anshul. I guess it's now time for some Q&A.